Good afternoon, students. Welcome back once again to the mathematics class. So, in today's lecture, we are going to study linear differential equations, right? Linear differential equations, right? It is a very important as concerned to our JEE. Already we have studied variable separable method and homogeneous method. In that, homogeneous is especially important for boards, whereas variable separable and linear differential equation, especially linear differential equation, it is a very important with respect to JEE exams, right? So let's see what is linear differential equation first. Equation of the form, let's see the definition of linear differential equation. This definition. So the equation of the form dy by dx plus py, which is equals to q, is known as linear differential equation. In y, because here y is the function, right, is known as linear differential equation in y, where p and q are where p and q are functions of x, where p and q are functions of x, this, right, functions of x, that is independent variable x, or constants but not of y, but not of y, right? Only these are the functions of x, this term. It is function of this x term, right? Where p and q are the functions of this independent variable x, where y is the equation of the form dy by dx plus p of y, which is equals to q, is known as linear differential equation in y. This is y is a function here, right? In terms of y here, y is the function and it is a dependent variable. Usually an equation consisting of a dependent variable y with respect to its derivative, that is dy by dx with respect to x, where y is a function, or you can say the dependent variable, and x is independent variable where y is derivative with respect to x, whereas p and q are the functions of what, this x. P and q are functions of this x, right? Both are functions of the independent variable x, or we can say they are the constants but not the functions of y. P and q are functions of x only, right? Just keep in mind. So here let's see how to solve a linear differential equation. There is a method is there, so let's see that. Already you know what is a linear differential equation, which are, and one more thing here, uh, where y and, that is the function and its derivative, they are not multiplied together here, they are separately mentioned here, dy by dx plus p of y is there, right? So y and dy by dx, they are not multiplied together, so just keep in mind this thing also. So next we will see the working rule. See, working rule for solving working rule for solving dy by dx plus P of Y, which is equals to Q, right? So in the first step, step 1, find the integrating factor. Find the integrating factor. Integrating factor, that is in short what we can say it is IF. The integrating factor formula is e to the power of integration P dx, right? Next in the second step 2, multiply both sides of a given equation by integrating factor, that is by IF, right? Next in the step 3, integrate both sides. Integrate both sides of a equation both sides of the equations obtained in step 2 to get the solution y into integrating factor, which is equal to integration of q into integrating factor with respect to x plus of c, right? This is our required solution. This is the required solution. What we can do here first in working rule, first we have to find the integrating factor e to the power of, already we have the standard form, right? It is dy by dx, which is equal to dy by dx plus p of y, which is equals to q, where p and q are the constant of a function x and y is the function of this equation and it's a derivative dy by dx. So our integrating factor is e to the power of integration p dx. Here we are using this term p with respect to x, we are integrating, where e to the power of integrating p dx. Its first step, we have to integrate the integrating factor e to the power of, either it may be anything, p may be anything, right? We will see some examples also. The next case, multiply both sides by the given equation by integrating factor, this if, multiply by integrating factor, and finally integrate both sides of the equation obtained in the step 2. After multiplying integrating factor, we have to integrate to get this final solution. We get this equation, right? So this is nothing but our required solution of linear differential equation, right? Let's see first. General form we will see. Let's see. Here a differential equation is of the form a differential equation is of the form dy by dx plus py, which is equals to q, is the right. So it is a standard form. For example, let us consider here. For example, dy by dx plus x square y, which is equals to x to the power of 4, right? So what we have said here, just now compare this equation 1 with this example. What we get here, the value of p and q are here. Here value of p is, when you compare with p and this p, value of p is what? X square, and value of q is what? x to the power of 4. Both are what? Both are functions of this x, right? Already we said here this x square and this x to the power of 4, that is p, and it is p, it is q. This p and q both are what? Functions of x, right? So p equals to x square and q is equals to x to the power of 4, right? Next, one more example you will see here. dy by dx plus y upon x, which is equals to x square, is that right? See here also value of p and q are functions of what? X only, right? So here p equals to what? 1 upon x is there, right? Now in the standard form, if we convert this equation, means what we get? Dy by dx plus py, means here p means 1 by x and value of q is x square. Again, both are the functions of what? This x only, right? These are the examples. Let's see now example how to solve a differential equation. The first example is, already you know the procedure how to solve a differential equation. Now let us consider first example 1. Solve dy by dx plus y, which is equals to e to the power of minus 3x, right? It has been asked in Punjab board also, this question in 2007. So the solution is here. Solution. The given linear equation is, write down, the given linear equation is dy by dx plus y, which is equals to e to the power of minus 3x, right? So now comparing with a standard form, that is dy by dx plus py, which is equals to q, then we have p equals to what here? Yes, p equals to 1 and value of q is e to the power of minus 3x, right? So now we have to find integrating factor in the first term, right? That is I f, which is equals to e to the power of pdx, which is equals to e to the power of integration of p value is 1 here, right? With respect to dx, means what we get here? E to the power of x only. So now multiply 1 by e to the power of x. Let us consider that as first equation 1, right? This is our equation 1. Multiplying 1 by e to the power of x. Multiplying 1 by e to the power of x, and then we get, let's see what we get if you multiply equation 1, e to the power of x, that is integrating factor dy by dx, plus y e to the power of x, which is equals to e to the power of minus 2x, right? Already minus 3x is there. If you multiply e to the power of x, means what we get here? E to the power of minus 2x. So now, which can be written as, which implies d by dx of y into e to the power of x, can we write like this? U into v form, it has been differentiated u into v form. So we can write it as d by dx of y to the power of x, which is equals to e to the power of minus 2x, right? E to the power of minus 2x. So now integrating, what we get here, if d by dx goes on RHS, or integrating both sides, what we get? Integrating. Then what we get here, integration and differentiation both get cancelled. In the LHS, what we get, only y e to the power of x integration of e to the power of minus 2x with respect to x plus of c constant term, right? So again, which is equals to y e to the power of x as it is. Here integration of e to the power of minus 2x is e to the power of minus 2x upon minus 2 plus of c. So finally y equals to minus 1 upon 2 e to the power of minus 3x plus c e to the power of minus x. Just we are taking this e to the power of x term to the RHS. So what it becomes, minus 1 by 2 as it is here. If it comes e to the power of x in the denominator, means if cross multiply it again, what we get, e to the power of x is there. If it goes to numerator, what it becomes, e to the power of minus x, e to the power of minus 2x, minus x is e to the power of minus 3x. So again, if you multiply this term, what we get, e to the power of c into e to the power of minus x, right? This is nothing but our required solution, that is y equals to minus 1 by 2 e to the power of minus 3x plus c into e to the power of minus x is nothing but our required solution. Got it? What we have did here, just initially we have find out integrating factor first, later on multiply that integrating factor and integrate it. Finally we get the required solution. Next, see the second example. It is example 2. Example 2. Solve the differential equation. Solve the differential equation dy by dx plus y upon x, which is equals to 2x square. It is also asked in Haryana board in 2007. So the solution is, a given linear equation is dy by dx plus y upon x, which is equals to x square. What we are doing here, simply we are finding the function y here. Finally our solution is what? Value of y only, right? So write down, take it as equation 1 here. It is minus term actually. This term is minus 1. So it is minus. It is also minus, right? Dy by dx minus y by x, which is equals to 2x square. Take it as equation 1. So now comparing with dy by dx plus py, which is equals to q, right? So we have value of p is here. We have p equals to what? Value of p is minus 1 by x and value of q is 2x square, right? So now we have to find integrating factor, which is equals to e to the power of p dx, right? It is the integration of e to the power of 1 of x into dx, which is equals to e to the power of minus take outside, integration of 1 of x dx, which is equals to e to the power of minus log mod x, or which is equals to e to the power of minus take to the numerator in the power form by using logarithm property. What it becomes, e to the power of log x inverse, means what we can write here, e to the power of log, we can write it as 1 by x. Here what we get, e to the power of log 1 by x means, which is equals to what, 1 by x only. Just keep in mind, e to the power of log anything it may be, log anything, we are taking log x, so which is equals to what here, e log it cancel, only what we get here, x only, this term only remains, right? So similarly here also e to the power of log 1 by x is there, only we got 1 by x, right? So now multiply equation, multiplying 1 by x, multiplying 1 by 1 by x, that is integrating factor, then we get 1 upon x dy by dx minus 1 upon x square y, which is equals to 2x. So here we have reduced the values, 1 by x multiplied to the first term, in the second term 1 by x square, already minus y by x is there, so if we multiply one more x means it becomes y by x square, that is nothing but minus 1 by x square into y we have written, and which is equals to 2x square is there, if we divide by x means 1x in the numerator and one more x in the denominator get cancelled, only 2x remains right here. So now this term can be written as from LHS, it is nothing but again u into v form, it is nothing but t by dx of y into 1 upon x, right? Can we write like this, first function as it is, differentiation of second, plus second as it is, differentiation of first, right? So which is equals to 2x. So now integrating what we get here, dy by dx get cancelled, d by dx, only y into 1 by x, integrating 2x dx, right? So plus of c as it is, constant term, therefore y into 1 upon x, which is equals to x square, x square by 2 is there, 2 to get cancelled here, x square plus of c, therefore y equals to, finally, which implies y equals to what we get here, x cube plus cx, which is nothing but our required solution. Got it? Here how to solve a linear differential equation by using integrating factor. First find out integrating factor, later on multiply it to the equation 1 and integrate it again. So finally we get the required answer, that is the function y, right? So next we will see one more example, or you can try at home yourself. I will give homework, one or two examples. That is next example. Example 3. Try yourself at home only. Solve the differential equation. Solve the differential equation. X plus 1 dy by dx minus of y e to the power of 3x x plus 1 whole square, right? So here we have to convert it in the standard form again. Let's see, I will solve this one only. A solution of this, first we have to convert it in the standard form. A solution, here the given equation can be written as dy by dx minus of, here what we are doing, dividing by x plus 1, right, which is equals to e to the power of 3x x plus 1 get cancelled, means here only x plus 1 remains. So what we have done here, dividing by x plus 1, both side we have divided by 1 upon, it is dividing by x plus 1. So in the first term x plus 1 get cancelled here, in the second y upon x plus 1, in the third x plus 1 is there, again it cancels. Now it is in the standard form. Now comparing with, now compare, take it as equation 1, comparing with dy by dx plus py, which is equals to q, right? So here the value of p is what, minus 1 upon x plus 1, and value of q is e to the power of 3x x plus 1 is there, right? So now integrating factor if, which is equals to integration of pdx, so which is equals to e integration of minus, keep outside, 1 upon x plus 1 dx, which is equals to e to the power of minus log x plus 1, right? So here again, applying logarithm property, it becomes log 1 upon x plus 1, again e to the power of log get cancel, only what we get here, 1 upon x plus 1. Now multiply 1 by 1 by 1 upon x plus 1, right? Multiply equation 1 by x plus 1, then what we get here, simply 1 upon x plus 1 dy by dx minus of y upon x plus 1 whole square. I'm writing directly y upon x plus 1 whole square, which is equals to e to the power of 3x, which is equals to e to the power of 3x. Just we are multiplying equation 1 by 1 upon x plus 1. So in the first term, 1 upon x plus 1 dy by dx minus y upon, already x plus 1 is there, x plus 1 whole square, and which is equals to e to the power of x plus 1 here get cancelled from numerator and denominator, so remains only e to the power of 3x. So now which can be written as again in LHS form. It is very important, it is dy by dx, it is given to u form, you will get always given to v form when you substitute this kind of values here, and finally you get y, we have to convert it in the form of u into v only. So y into 1 upon x plus 1, which is equals to e to the power of 3x. Now it is in the form of u into v. After differentiate, you will get the same term as in the above equation. So now integrating y 1 upon x plus 1, here d by dx get cancelled, integration and differentiation both are inverse process. So in the RHS, integration of e to the power of 3x dx plus of c. So now, which implies y into 1 upon x plus 1, which is equals to integration of e to the power of 3x is 1 upon 3 e to the power of 3x plus of c, right, which is nothing but our required equation. Or you can take x plus 1 to this RHS, it becomes y equals to 1 by 3 e to the power of 3x x plus 1 plus c into x plus 1, hence which is nothing but our required equation, right? So this much is in this lecture series. Next, in the tomorrow's lecture, we will see some more examples based on linear differential equation. So till then, take care, stay at home, stay safe. Thank you.